So, to start with this session on space and artificial intelligence, we'll stay very close to Earth. And we are going to look at maps. Not only maps with roads, highways, and bridges, as you are used to it, but more generally, maps of human activity. Agriculture, land use, forestry, change map, risks map. We are facing three main trends which have drastically changed the geospatial imagery industry in the recent years, and that will continue to change this industry. First of all, the EO satellite, the Earth observation satellite, increasing capacity in sharpness of images, in coverage, and in frequency of revisit of different points of the globe, but also in new measurement techniques, like it can be with LiDAR or hyperspectral instruments. And those satellites, they are delivering daily, every day of the year, huge quantity of data, petabytes of data. This is the first trend. The second one is that we have now almost unlimited access to computing power for storage, for computing, thanks to the cloud technology. And the third one, of course, is artificial intelligence that can allow image processing which are much beyond what human photo interpreters or classical algorithm can do. So, as you can see in the public domain, on your smartphone or on your computer, artificial intelligence has produced a lot of analytics to process images, to detect objects, to classify, to recognize, etc., etc. And this has also applications in satellite imagery, especially in the defense domain, where you can classify aircrafts, battleships, you can survey strategic sites, etc., etc. But today, we are going to focus on a specific kind of maps, which are the Anthropocene maps. Maps no less than providing us information about human activity on Earth. And for that, we are very pleased to welcome Nicolas Gonthier. Nicolas is the head of artificial intelligence and change detection at IGN. So we are really talking about application there, not about space hardware. And he's leading the artificial intelligence department, and he will tell us how artificial intelligence contribute to this maps generation from space and how it can help us to understand the Anthropocene. So, Nicolas, the floor is yours for the 15 minutes to come. Thank you.
Waiting for the presentation to be on screen, Renaud Allioux of Preligens, now Safran AI, has unfortunately had a personal problem and he cannot meet it, he cannot be there today. So Nicolas is the only panelist on this topic. Sorry for that, but we have to forgive Renaud.
Hello everyone, I hope it will be an interesting presentation for you. Slightly different from what you have seen today and yesterday. So I will speak about the fact that at IGN, where I am a member from, we are using AI for different use. First, I will give a brief overview of IGN mission and what we are looking for. Then, why we can use AI in cartography in general. And then I will focus on one specific example of AI at scale and how we can use it apply it at a national scale. IGN, as you may know, is the French National Institute for Geospatial and Forestry Data. Our mission is to observe, measure, and describe the territories. It's a public institute, so a non-profit under the supervision of Ministry of Ecology or Sustainable Development and Ministry of Agriculture. And our main goal is to describe the soil, the different land, their use and their occupation, and also the forest resources, then to be able to represent them and to distribute them to anyone. and also to the different, to be used for the different public policies. So the 8 main challenges of Anthropocene that you may know are the climate crisis. So it's like to be able to map urbanization, a risk, for instance, flooding, forest, it could be forest help or forest resource, biodiversity, agriculture, coastline, the water resources, but also the energy. The goal of IGEN is to provide sovereign data on all the French territories, metropolitan and overseas, for sure. For that, we have the full pipeline of data from HAL and spatial image acquisition, and also HD LiDAR. Then we provide some topographical vector data and altimetric information that could be used, for instance, from flooding simulation. We also provide thematical data like land use, land cover, or forestry, as I mentioned before. And then we also provide a data portal to be able to use all our information and all our data. Everything is free and can be used by any citizen, company, or public sector. And we're also working now about different technologies such as AI, I will speak about that today, but also digital twins to have a kind of 3D representation of the territory and to be able to run some simulation or prediction of it. Then I will give you a few examples of AI that we can use at IGEN. First, I would like to say that at IGEN, the main data source we are using as input is very high resolution aerial images we are acquiring, but now we'll also focus on some of the space-borne images we can get. So the first use is land cover. That means it's trying to be able to, from a given very high resolution images, be able to say that we have buildings, vegetation, water, roads, and a lot of different things on the ground, and be able to map them very efficiently. And AI is a way to do it more faster than previously by first trying to apply prediction models, so like semantic segmentation model, and then to refine them by human operator. I will speak later about that. We can also use AI, for instance, by using Sentinel-2 time series in order to be able to detect heterogeneous agricultural parcels. That means parcels where you grow two kinds of plants and not only one. That could be useful for the common politics of agriculture in Europe. So here you have an example where in red you have the parcels that are heterogeneous, and in blue the homogeneous one. We can also use AI for LiDAR semantic segmentation. So in this case here you can see LiDAR that we acquire in an urban area, and where the building have been colored in red, in green you have vegetation, the soil in orange, etc. And that could be also very useful then to, for instance, determine what is the ground for a numerical model, or for different kind of use. It could be used for estimate the solar panel that could be installed on the top of buildings, for instance. LiDAR can also be useful for forestry, where you can try to detect the different type of trees or species of trees, and thanks to LiDAR images, and that we classify by AI model. And another application is once again with space images, like especially Sentinel-2 and Sentinel-1 images, we try to detect what we can call parcel management or agricultural event, where they are harvesting or mowing, and we can see them, for instance, on the top in the time series where there's kind of a drop, and so we try to detect this kind of information automatically. So the take-home message is that AI could be very useful in a lot of different cases, and it's very good ally, especially when you need to scale up. That means when you need to apply it to a very large scale, and to have something will be systematic, to have the same thing all over the country. And it's technically rich because, as you can see, you have a lot of different input data, and it will change the type of model you will use depending on this data or depending on the task. If you try to do change detection, it will be not the same that doing semantic segmentation or regression or something else. Now we'll give an example of AI at scale, and especially speak about open source dataset we create at IGN, and we, as I mentioned, outsource it, so then everyone can use it. It has been developed for the land cover layer that have been asked by the Ministry of Ecology, also called OCHGE in French. But we needed to reformulate the final task, so have this vector layer, to something that could be learned by AI model. So for AI model, the task is to predict for each pixel a class given a semantic nomenclature, and say, okay, this pixel is a pixel of building, this one is a pixel of coniferous, this other one of brush, or this one from vineyard. And what is, we do it like that in order to be able to train very efficient semantic segmentation model that have kind of part model that can be, and for this task we can use deep learning model. So this dataset is very huge in terms of scale and resolution, because we have something like 800 kilometer squares at very high resolution images that have been annotated by hand, as you can see on the left, with manual checking, manualization, and then checking to be sure about the quality. And we sample it in all over the France in order to have very broad diversity in the different roof or vegetation as that we can see in France. And this work is now open source, and it has been published in some scientific conference in AI. And we also decided to add not only the RL images, high resolution acquired by IGN, which is monotemporal, but also Sentinel-2 images on the same area in order to have more information, especially about vegetation, because you will have the phenology, for instance, of the plants that could be very useful. And so on the same area, you will have both the RL images and the Sentinel-2 time series with bigger spectral resolution and broader spatial context. And now we are preparing a new version of this dataset, which will be 3 times bigger. And so what you can learn is like a classical semantic segmentation model, here called UNet, and you can get something like 45% of MU, so it's like it's the mean of the metric that you can compute on different semantic class. And we show that by adding the Sentinel-2 images on the same area, you can improve the performance. And on the left, you have the aerial images. In the middle, the ground truths that have been annotated by hand by human. And on the right, the prediction. And so this is the input from our production process at IGN that will be then corrected by human. So we still have human in the loop in order to reach the very high quality demand from the ministry. And then it will be vectorized and become a kind of new vector map that could be provided. For instance, this could be used for the computation of zero articulation nets, so ZAN in France, because we will be able to run the same kind of things every 3 years and be able to know that, for instance, in this department, we have this new amount of new buildings. Something that can be also interesting for you is what is in the future. So now we have this model, it's worked pretty well, what we call RL model, but we also will try to apply it to new kind of images. So here it's an example of Pleiad Neo images, you maybe know, so satellite images at 30 centimeters square with RGB infrared, but also deep blue canal. And what we show is that, in fact, when you apply directly the model on this kind of images, which is not so far, it's not worked so well, but by you can fine-tune it, that means modify slightly the parameter on this new kind of sensor by only annotating 200 kilometers square, so less than what you have annotated first, to get comparable performance. And we're also trying to apply it, for instance, on other kind of images such as Spot, which has low resolution. So the different challenge we are facing at IGN, the first one is the one about human resources and organization. So to be able to develop all this kind of AI system, we were able to hire more than almost 30 AI experts in the last years. And we also have a research team with an academic research lab at IGN with more than 25 researchers working about AI topics. And we also have a lot of people in all the different cycles, from innovation, development to production, to be able to develop the best model we can. But we have a very strong competition for AI talent, as you may know. We were able to hire so much AI experts thanks to sense of mission with public services and ecology tasks. The fact that we will open source the dataset, as I show you, but we will also open source the model, the code to train them, and the final prediction. We try to work a lot about keeping a scientific and technical credibility. So as I mentioned, several of our work have been published in some different AI conference in order to disseminate the information, but also to get more information. And to have large-scale contribution. With fact, to open data could be very useful to get more information, and it helps the other partner to develop with less cost. But it's important to have a multidisciplinary team where you have both people able to develop AI system, but also photo interpreter, geomatician, and other people knowing geospatial data. But it's demanding projects with resource intensive. A lot of GPU are needed to train this kind of model, especially when you need to try a lot of different things, different architecture, different elements. And it's still experimental. You cannot say at the beginning of the project that it will succeed. Très bien. So as I mentioned, is pretty computing demanding. And so we now have a sector with a lot of concentration, especially with few players. And in our case, we rely on public cloud provider, but it will maybe not always be the case. And so we also have ecological issue and sobriety. We try to develop models that are performant, but not too costly. And my last point is like the fact we try to stay at the state of the art in AI by trying to collaborate the most with academia and private sector. And to conclude, I will say that the success for AI project is a requirement of a lot of different units in all the cycle, signal management, also advanced to be able to have something that will continue in the term. There are no quick win. You will need to put effort, so it could be annotation effort, resources, and human resources. And it's still empirical approaches when you start small, and you will then increase your model and your capacity.
Thank you, Nicolas. I remind you that you still have the QR codes available for the questions you may ask. It's valid as well for the space session. There is a question on the log there about, let's say, a little bit more military aspects, I'm afraid. Is AI possibly useful to deal with camouflage and actually detect objects of interest despite protection? It's a bit focused. Maybe Eric can help you, Nicolas, if you need.
I can try. I think, especially in this different computer vision model I provide, really the model is really able to only detect what is seeing, and so it could be fooled by I think some camouflage, real-life camouflage, or also what you can call adversarial attack, where you will manipulate the images in order to not make them recognize them, to not recognize the object. So I think it will be not the case yet.
So the false, let's say, the false alarm may be too many. That's what you say. Okay. And there is another one which let's say tackles the from space. You can access huge surfaces, let's say millions of square kilometers. Are there artificial intelligence processings that may simplify the surveillance of these huge areas? For example, detect a mobile behavior by analysis of what he's doing, say, in order to target this. Imagine you've got a desert which is almost empty, and you have to detect something which is ongoing, but on which you cannot have humans looking at everything.
I think AI can help you to, as I mentioned, to do it at scale and to be able to process a very large amount of data if you were able to train efficient model first. But I think there are no technical limitations to do that.
Okay.
Maybe to complement that, of course, when you have several satellites in orbit, you can revisit a site many times daily, and you can detect the changes between two images. And of course, you cannot get a video of what's going on, but you can see the changes, and the AI is very useful to detect those weak signals and raise a warning about something is going on there. And the intelligence of strategic sites, thanks to several in-orbit satellites and artificial intelligence, is something which is an operated application, I would say.
There is a last question, and then we'll switch to the next panel. The question phrase, thanks Nicolas, could you tell us more about the adoption by photo interpreters and the win-win game with them?
Yeah, no, it was a very good question. So at Hygiene, some of the people were afraid that AI system will replace them, especially because I have photo interpreter skills. But in fact, it's like we see more the AI system like something that will help them to process more data quicker. And they will also try to teach the model by trying to correct them, for instance. And so we try really to focus on the values that will bring the fact that are better. The photo interpreters are still better than AI model. AI model just help us to do it quicker. And so for now, it's not. It was a question at the beginning of some of the project, but now it's less the case.
Good. Sounds good. Thanks, Nicolas. Now we'll give the floor to Eric Souler's team